Making this mistake in your house construction could literally cost you thousands of dollars. Imagine excavating the site, pouring the concrete, framing all the walls, and then, a year later, crack. Your entire investment is literally sinking into the ground. It's an absolute nightmare, but hey, it does not have to be that way. Here's exactly how to avoid it.
In this explainer, you're going to learn exactly how to choose the right foundation so you don't accidentally build on a ticking time bomb. Seriously, why do foundations fail and crack the entire house? Well, it almost always comes down to picking the wrong structural system for the specific ground you're building on. But there is one important detail about your soil that you absolutely cannot afford to miss. We'll cover that in just a sec.
All right, let's dive right into this. The number one concept you need to understand is called differential settlement. This is the ultimate threat to literally any building. It happens when one part of a foundation settles into the earth way more than another part. Just imagine the left side of your house sinking 2 inches while the right side stays perfectly still. That uneven settling will literally rip load-bearing walls apart. And you know why it usually happens? Because the soil's bearing capacity was completely ignored before pouring the concrete.
So here is the crucial point. Soil bearing capacity is basically your foundation's foundation. It's that important. Every single foundation decision you make absolutely must start with a geotechnical soil report. You need to know exactly what's happening beneath the surface because your structure is only as strong as the dirt beneath it. Never guess, always test. Seriously, skipping this report is the biggest mistake you can make.
Okay, so assuming your soil report comes back with good news, let's look at your first option, shallow foundations. You're going to use these when you've got strong, competent soil within about 8 feet of the surface. They work by spreading the building's loads right across the surface of the earth. And because you don't need any highly specialized, massive drilling equipment to put these in, they're definitely the most economical option available. When you're staying close to the surface, you generally have 4 main options that most residential and light commercial structures rely on to safely transfer that weight to the ground. We've got the individual or spread footing, the continuous or strip footing, the combined footing, and the mat or raft foundation. Now, most beginners get this wrong, so definitely pay attention to this comparison. On one hand, we have the spread footing. It's incredibly economical, but why? Well, because it's specifically designed to support single, isolated columns with really clear load paths. Now, compare that to the continuous footing. This is the absolute go-to standard for residential houses. Why? Because it sits directly under and supports continuous load-bearing walls, which safely distributes all that massive weight evenly. You always have to match the footing to the specific structural load. But what if that surface soil is a little weaker or maybe highly variable? Well, that's where you must use a mat or raft foundation. I like to think of this one like a giant snowshoe. Instead of pouring narrow strips, it's a massive concrete footprint that covers the entire building area. By acting as one single mat for all the structural elements, it spreads the load out and completely prevents that disastrous differential settlement we talked about earlier. But here's a big question for you. What happens when your geotechnical report comes back and tells you that you've got 20 feet of super soft clay before you hit anything remotely stable? Yeah, even a massive raft foundation won't save you here. You have to bypass that weak, unstable surface soil entirely. You've got to go deep to avoid a costly failure. And when you have to go deep, enter pile foundations. Think of these as giant stilts made of slender columns of steel, concrete, or wood. They are driven or bored super deep down until they reach stable bedrock or incredibly stiff soil. And they're totally amazing because they don't just support heavy compressive loads pushing down, they also resist upward tensile forces. That's what prevents flotation if you happen to be building in a high water table.
Now, for massive structures, we use caissons, which are also known as drilled piers. We're talking about massive 2 to 10-foot diameter shafts drilled straight into the earth and filled with reinforced concrete. And in just incredible engineering fashion, they can actually be belled at the bottom, so they're shaped exactly like an elephant's foot. That bell shape dramatically spreads out those tremendous, concentrated point loads.
Hey, don't make this mistake before starting construction, picking the wrong deep foundation installation for your site's surroundings. Just look at the contrast here. Driven piles are fast, yeah, but they're incredibly noisy, they cause massive vibrations, and you essentially just have to trust your driving records. Drilled caissons, however, are quiet and produce minimal vibration, which makes them absolutely perfect for tight urban sites next to existing buildings. Plus, caissons actually allow engineers to visually inspect the bedrock before pouring the concrete. That's a huge win. So how do you actually choose?
Well, I've put together this ultimate matchup matrix. Most beginners get this wrong, but this table makes choosing between strip and raft foundations incredibly simple based on your soil and your budget. If you have good uniform bearing capacity, strip foundations are low cost and highly efficient. But if you're dealing with weaker soils and a larger footprint, the raft foundation takes the win every time by safely spreading that load right across the entire structure.
If you want more practical construction tips and calculations to help you master these engineering decisions, subscribe to Construction Learners. Go ahead and hit that button right now, because stay until the end. I'm about to show you the easiest way to calculate deep foundation settlement, followed by 5 non-negotiable pro tips for your next build. Okay, for all the civil engineering students and structural designers out there, this one is for you. This is the static analysis formula framework used to calculate the elastic shortening and settlement of deep foundations. You're basically factoring in the applied load, the cross-sectional area of the pile, the elastic modulus of the pile material, and the pile embedment length. Calculating this accurately is exactly how you guarantee the structural performance of a deep foundation when it's under immense stress.
Now, let's walk through the 5 non-negotiable steps for effective foundation construction. Step 1. Understand your soil types using a geotech report. Step 2. Ensure an accurate layout using professional surveying equipment. Step 3. Plan your water management. Step 4. Choose the right foundation type for the load. And Step 5. Always use quality materials. Compromising on literally any of these 5 steps will absolutely lead to a future structural disaster.
Actually, I want to focus heavily on step number 3 for a moment. Listen to me. Water is the enemy. Contractors, you have got to plan proper drainage and robust waterproofing. Water can so easily undermine a perfectly poured foundation, causing settling and shifting. You can literally have the best concrete in the world, but if water pools around it, that foundation will fail.
So, let's summarize the core lesson practically. Use shallow foundations when you've got strong, competent surface soil. And use deep foundations to bypass the weak stuff when your surface soil is unstable. But never guess, always test. Every single choice must be based on a professional geotechnical report.
If this explainer helped you, subscribe to Construction Learners. We regularly share practical construction knowledge that can help you build smarter and avoid those really costly mistakes. And in the next explainer, I'll show you exactly how to calculate concrete volumes, so make sure you don't miss it. Until then, ask yourself, what kind of soil are you really building your dream on?